For today's episode, I have a soy milk mocha with marshmallows and maple syrup. Today we're covering data types, so sit back and relax and let's get into it. Alright, so in today's video we're going to be covering C++ data types. Data types are basically memory addresses that you use to store things. So if I open Atom up and I just will grab this, open our folder, and I'm going to actually delete the old file. Get us a brand new, brand new C++ document. Main dot. Just drag that into there. All right, so here we go. Sharp include IO stream, and in this stream we're going to say using name space std int main, and we're going to do this and say return 0. So everything in C++ is basically memory addresses. In the case of int, this for int main here, main is the name of an integer. An integer returns a number. So if I was to later on in another function, if I had main2, if I had void main2, and I said I wanted to call, or here, how about this? I'll say int main2, and I'll say int main up top, because I should mention that programming languages start at the top and run each line after it. So if I have main2 down here, then I need to make sure the compiler knows about main2. So I put it up top with a semicolon rather than open it. So now it's gonna, when it reads this, it's gonna call this. So in main2, I'm going to say main2 returns 42 always. So in here, cout, I'm going to say main2, and actually, we'll just say c std lib and system pause. Alright, so this is our script. Main2 returns 42. If we output main2 in a cout function, we should get the number 42. And we've made sure we can read main2 by referencing it above here. That way when main hits it, we know it exists. So if I compile this, and then I run it, don't forget the brackets behind main2. Good advice. So compile that. 42. There you go. So this is one type of setting a data type. This is where it returns a number. Main is the same kind of thing, except main is always called first because it's named main. So things we can do if we don't want to reference it above, we can actually put main2 before main for the first main. So if I do this and then call compile and run it, you'll see that it compiles then we don't have to reference main2. So this is a strategic way of keeping your data types like this. Now here's another data type. I should mention one thing. If you create a data type inside of another data type, like this could be a int I equals 1, and then if I tried to output I right here, it has no idea what I is and will probably give me a compile error. Yeah, see, it doesn't know what I is because I only exists within this int. So in this case, what I'd have to do to make I referenceable out here is I'd have to put I in the global space. So this is int I equals 86. So now I can just use an equals operator to set it to 86, and if I compile this and run it, 86. Good. So inside of global space, if I was to move this integer into global space, into local space, here it is. Oops, my bad. Gotta compile. Should be the same. Yeah. All right, so that's that. Next is the different types. So an int is a number with no decimal places. That means if I put a decimal in, it's not going to like that. So an int is also a 32-bit number only. So that means it has a minimum value that it can be, and a maximum value can be. It's a little over 2 billion negative and positive numbers. So this is a negative, it's positive. I can also put a plus symbol in front. It doesn't object to that. I can also put equations in here. So 1 plus 1, 2. This is the multiplication symbol. This is the division symbol. And we'll get into things like powers and exponents in later episodes. But basically, things to remember is 1 minus this. Division minus symbol. Alright, so another thing an integer can equal is integer can equal itself plus 1. That's interesting. I should probably output it, so I'll actually copy that. Actually, here's what I'll do. I'll say it equals I. I'll return I instead of 42. So it outputs main2. As you can see, it's equal to 1. So if I was to, instead of this, say is equal to 1, rather, even better, I'll create I, and then in the next one I'll say I equals 1, and then I'll say I equals I plus 2, like so. And then I'll return I. Now it's equal to 3. So that is data types. Using that's how you return data types. That's the explanation for data types like this. And if I wanted to put this afterwards, like so, if I compile this, you'll see, oops, wrong. If I compile this, it doesn't like it, doesn't know what it is, doesn't know what main2 is. So all I have to do after that, int main2, and this is generally speaking what I do for form. It looks nicer having my stuff after main. So there you go, now it's 3. Because now this is called first, because it's looking for it thanks to this. So next, let's get into the other data types. I'm going to create a bunch of global data types, and I'm just going to run through each one of them. So I have an int, or we already have ints, so we'll say next we're going to have a float. Float f is equal to 1.3, double d is equal to 2.4 and a bunch of numbers, bool B is equal to true, and we'll say char C is equal to C. We'll say string lol equals lumpology. So here's a whole bunch of things to think about. So let's output all of these. So we have our integer, we have I. Now we're going to have F and D and after D we're going to have B, and after B we're going to have C, and after C we're going to have lol, like so. So this long cout string here, we're going to compile that. And as you can see, there was a problem. So you know what this is? This type of char is not a recognized type. So you'll run into stuff like this. And you know why this is? Chars are not actually designed for stuff like this. Char types are, well, they hold single types, but they're meant to be used in arrays and in sequential format. Because of this, oftentimes what I'll do after this is I'll just put 2 square brackets, like so. And as you can see, that works. So this turns it into what's called a C string. So C strings basically mean you can have a sequence and it adapts to however long your sequence here is. C string. So let us output this. So as you can see, what we have here is 3 for main 2. We have 86 for I, 1.3 for the float, 2.44535 for the double, 1 for the boolean, C for the char, and lumpology for the string. So what we have here is basically all of the accepted main data types that you'll be using. 32-bit float, 64-bit float, a true or false statement, an unstable string, and a more modern stable string. So things we're never ever going to use again: chars. Chars are old. That's C business. We don't use C stuff anymore. So we're never going to use a char again. We're only going to use strings from here on out. There are reasons why char exists, and in fact the fundamental basis for the string is a char. However, we're still not going to use it. Strings are modern, we have all kinds of features, and speed is not the biggest concern when you're using a language like this. So, with C gone, I'm just going to remove it from here. And now that we have these types, we're good. So, we can now expand on this. So, things to note. Another way of inputting a string, you can put it in brackets. Brackets are just your typical brackets. So the order of operations is still recognized. If you know an American system, that's called like bed mass. Brackets, exponents, division, multiplication, addition, subtraction, that works in C++. So order of operations is something that will have to be considered in some situations. However, it can easily be bypassed. There's another data type I'm not really including here. It's called the void. Voids don't have anything in them. They have no storage operator. We only generally use voids in place of these integer functions. So instead of int main2, I can say void, and then I can say name, my name, and these are just like places where you can put commands. Basically, there's no fundamental reason to use a void for anything other than this. You also don't need to return a void. Well, actually, you don't need to return any of these statements. You don't need to put this return statement. However, in integers, it's generally accepted that you put the return statement in. In a void, there is a return statement, but just put it. All you have to do is just put a semicolon right after. You cannot return a number. It'll form a syntax error and won't compile. So this is a void. Voids are designed so you can put like a cout statement in there, or do something mathematical in there with a global variable. You'll never really use a void. Another thing to remember, global variables can be accessed in any function, however they are not secure. If you want a secure function, keep it inside a namespace like this. Do not rely on global variables for anything that needs to be secure. If your program has a password in it, do not put it in a global variable. They're not secure types. Anyways, let's move on. So there are other types. So if you have a Boolean, that a float is a 32-bit float, double is a even longer float, but that's really their size in bytes. So there's actually longer ways of interpreting this, and it really depends on the language. So in other types, we can have, you'll see an unsigned type, the long type, and the short type. So these are generally included alongside regular types. So unsigned is there are no negative numbers in an unsigned number. It goes from 0 to the largest possible number, and you can technically get longer numbers than regular if you use unsigned. Long expands it. So for an integer, you can have a long integer, which has a larger number you can put in, or you can have a long integer, which is an even larger number that you can put in. I do not believe it goes past 64 bits. Actually, I think a long integer is still 32 bits. A regular integer is 16. However, yeah, it might be something like that. Anyways, that's not too important. All that matters is the amount of precision you can have. You can also have an unsigned long integer, or just an unsigned integer. No negative numbers in these. Only positive numbers. You'll also see things like int 32 underscore t. That is an older type of data type. That is a C data type. We don't tend to use those. You'll also see things like a char 32. It's a 32-bit char underscore t, like this. Once again, that's C stuff. We won't really get into that. There's also things as a null pointer, but we won't really get into that. Also, a shortens the number. Short integer is a small integer. So those are the fundamentals of data types. Not everything can be unsigned. There is such thing as a long double. They're not that much different from doubles. But anyways, yeah. And then a Boolean can only have true or false. There are other types of data types. Yes, there's a thing you'll run into called a size t. There's also a really neat data type called auto. Auto is like the JavaScript is like the C++ equivalent of the JavaScript var. It automatically determines what it is you're using. Never use it ever. It's bad, very bad, very bad. Yeah, that's my short description of what auto is. So thus concludes our section on data types. Here's an example of auto. Okay, so anyways, this concludes. So that is a data type. There's also a decal type. That is a null pointer. It's got nothing in it also. So pointers. We'll get into pointers later. Pointers are really neat stuff. We'll use them a lot, but we won't use them right now. So this is data types in C++. Feel free to experiment with them. You can output their size, I believe, by saying like cout size of, and then putting like int inside of here, and that will tell you its size. Here, I'll compile that for us. It didn't really like that. The reason it wasn't compiling was because I still had the program open. If you compile once the program is not open anymore, then it compiles just fine. So, for example, if I have output.exe open and I try to compile again, it doesn't like that. Really doesn't like that. Just FYI, things to remember. Alright, so, anyways, size of is a perfectly reasonable command to use. If I run that now, I believe it outputted the, 4, so that's the number of bytes in an int. So good. That concludes the video. Bah!